Hi John, I've managed to get audio working obviously, so I can explain my thought pattern and what I've done here. This is an approximate simple formula for Earth curvature with a scale model at sea level, not including refraction or anything else. So it is approximate purely because using a scale of miles to pixels, 1 mile equals 1 pixel. So on this model, the radius of the Earth, 3,965 miles, is in pixels. So there's 3,965 or thereabouts pixels on that radius line. This is a tool I've got here, which is a measurement tool, which is in pixels, as you can see up here. So we'll measure from here to here, and you can see it says 3,960 pixels, or 3,960 miles. We measure from the bottom to the top. 3,960 pixels. So this is the radius of the Earth. This is 1/4 of the Earth. That would be a north point, if you like, and that would be east. A, B, C, D and E are people on the Earth, which we're going to measure between to see what the curvature is. Now, in the incorrect model for maths, which is here, 8 times the length squared divided by 12 feet, 284 miles. For example, 2,500 miles would equal, using the incorrect maths, 789 miles in curvature. Whereas the correct simple formula equals the length squared divided by 8 times the radius. And that will give you the answer in miles. You divide by 5,284 feet. So for example, the same distance, 2,500 miles, would give you 197 miles, which is quite a bit different to 789 mile hump to 197 mile hump. So I'm a ball Earth skeptic as well. I'm about 80% flat Earth, but I couldn't understand why all of the flat Earth channels were using the incorrect maths for what is basically the main measurement that they take to try and prove, or you can take to try and prove that the Earth is flat. So my assumption and what is that water is flat. So we'll use that as an example. So say for instance from point A to point B, or person A to person B, if I zoom in a bit, where if person A stand on the Earth on one side of the water, this is the water, person B on the other side. The curvature of the Earth is represented by this curve, obviously, and this would be a flat Earth plane, or flat Earth sea, they call it. So the distance we're interested in would be the measurement between sea level here and the height of the curve. And this is the same for all of these distances. So from person A to person B, this is 1,562 miles. From person A to person C, 3,125 miles. A to D, 4,687. A to E, 6,250, which is 1/4 of the way around the ball Earth, taking it as 25,000 miles circumference. So these blue double arrows represent the point where we would measure from sea level to the height of the curve to get our distance on each of these. And because this is a model that is done every pixel measures a mile, by measuring these distances I'll be able to see exactly what the miles is of curvature using the model, and then I'll be able to check whether or see which maths is correct to give us the closest result to this figure. So basically what corresponds to one or the other. So we will measure and see. Now, point of fact, because I'm at such a high ratio of pixels in this area, then obviously the lines are quite thick. For example, I mean from here to here it measures 17 pixels or 17 miles. So there is some discrepancy allowed, but because of the large distance we're covering, we will get in the ballpark figure anyhow, and we'll see what we get. So person A standing here on one side of the water and person B standing here on the other side of the water. My common sense tells me that this water is flat, which would be represented by this blue line on this Earth model, and therefore we're measuring from sea level to the height of the curvature. So let's do that. Sea level to the height of the curvature. 70, well, in between, well, I mean it's going to vary a bit, but there is 78 pixels, or 78 miles. Let's see what the math says. Right, the math says person A to person B, which is from here to here, 1562 miles, 1562 miles, the curvature would equal 76.9 miles. Well, that's exactly what we just had. 76 here. The incorrect maths, incidentally, is 308 miles. Where from? I know not where. Doesn't make any sense. Even from here down to here, sorry, here and here, 263. Can't really see on that, but I'll show you. So let's zoom back in again so we can see a bit better. "76 miles, and we've got 77 miles, or 76, 77, 78, in between that figure, because we've got the differences on the widths of the lines, obviously. 300 and, was it 308 miles? Now, even from here up to the top of the Earth is 275 miles. So where is this 308 miles? It doesn't exist on this model in reality. The second distance we measure here, from here up to here, 302 miles. 302 miles. So that's from A to C, 302 miles of curvature. What does the math say? 307. Oh, 5 miles out. Incorrect maths, 1233 miles. From where? From here to where? Out in space. From here to here is 1140 miles. So 1233 miles. Don't think so. From our A to D, we're obviously going to get the same result. Sorry, A to D here, person to person, measuring 698. about 690. Well, measurement A to D, 692. 2,773 miles using the incorrect maths. Whoa, that's 2,400 miles. So 2,500 to the top of the Earth. 2,773. Where's that come from? From A to E, which, as I said, is like a quarter of the way around the Earth, 6,250 miles. Maths says 1,231 miles, the correct maths. The incorrect maths says 4,932 miles. Well, that's just under 1,000 miles longer than the radius of the Earth. So from here to here, 4,900. Well, from here to here is 4,600. So what is that measuring? Nothing to do with this. Our measurement, if one person standing here and one person standing here, and this is a giant area of sea, which is flat, the distance between sea level and the height of the curvature of a 25,000 mile circumference ball would be, what's that, 1,213 miles. 1,231, so the maths. Incorrect maths, 4,932. Well, if you measure it from here to where? To where? Here. Let's measure it up to here. 4,905. Yeah, that looks about right. So obviously the mass that's being used by every flat earth channel is incorrect, and I just want it sorted out, because if any tests are done and they use the incorrect maths, they're going to be debunked straight away. So they might as well use the correct maths to start with, and everyone knows where they stand. Down here I've just worked out some quick figures so we know. The correct maths for 4 miles is actually 2.6 feet. Incorrect maths for 4 miles comes out at 10.6. 8 miles is actually 10.6 feet. 8 miles incorrect is 42.6 feet. 12 miles is 23.9 feet. Incorrect, 96 foot. And 20 miles, 66 foot. Incorrect, 266 foot. As you can see on this example here, the 2,500 miles, which is one that Duran uses quite often for these California to Hawaii sketch across the ocean, and he says it's like 770 miles. Actually 2,500 miles is 789 miles on the incorrect maths, but actually the correct maths shows it to be 197 miles. So the correct maths actually gets ticked at every point. It actually works with a model that is actually correct in distance, 3,975 within 5 or 6 miles or whatever, but basically for this ratio and scale it works perfectly with the maths. So you tell me, which maths is correct? Is this the curvature that we should see from this distance, or this maths, 308 miles from what? From where? From where? Cheers. Jump.